Hi friends, this is a short and brief introduction to the concept of active learning as applicable in the context of machine learning and deep learning applications. Now, this is a short and brief introduction only where we'll explain the problem and introduce you to a simple technique, but it's not a dive deep because diving deep would take considerable amount of time. Now, let's set the problem. Imagine you have a large amount of unlabeled data. As you can see on the screen, let's call this data as a DU. And let's assume we have a smaller amount, relatively smaller amount of labeled data. Let's call that as DL. As you can see in the equation, DU is significantly greater or larger than DL in terms of their size. Now, in a lot of real-world problems, there is a cost associated with getting or obtaining manual or human labels. Let me give you an example. Imagine you have chest x-rays or MRI scans or photographs of the human retina. In such cases, you need a medical expert, typically an expert doctor, to provide the human labels. Or the actual labels, imagine if it's a multi-class or a binary class classification on whether somebody has a disease or not, right? You need human experts and human experts are expensive. Hence, obtaining human labels is also expensive. In any real world situation where you need a human expert who is very well qualified to provide the human labels or the manual labels, this problem typically occurs. This occurs a lot in medicine especially. Now, again, we want to build machine learning models. All we have right now is the labeled data. So first step that we would do is we will take all of this labeled data, let's call it as DL, which is a smaller amount of data, while the unlabeled data is significantly larger. We'll take this labeled data, build our initial model, whatever model, it could be a machine learning or a deep learning model. Let's call that initial model as M0. Now comes the fun part. Now remember, we have this larger unlabeled data that we still want to use, DU. Now can I somehow smartly pick some points from DU or sample some points from DU, right? And let's call that small subset that we sample. We have to smartly sample, not randomly sample. We have to somehow pick or sample smartly. Let's call that subset as S1, as you can see on the screen. Now, for this small subset S1, we will pass them through human experts, obtain the manual labels. Again, this S1 is typically small. It's significantly smaller than the whole unlabeled data. It's typically 1% or 0.1% of the whole unlabeled data. We smartly pick this and we obtain human labels. Now what we do is this. We have this newly labeled data S1. Now we will take our existing model. If you see, we have an existing model M0, right? So we will take our existing model, which was trained on the previously labeled data DL, and we will add this new data S1. And we can either retrain the whole model from scratch or we can update the existing model or the initial model M0 to obtain M1. Now, when I say we have to smartly pick or sample the data from DU, what do we want? We want a new model M1 to be significantly better than M0. That is our objective. That's the key idea of active learning. So, the problem of active learning is this. If you have a large amount of unlabeled data, how do you smartly pick or sample a small subset, let's say S1 of data from this, so as to maximize the lift in the model performance of M1 as compared to M0? Just to quickly recap, M1 is the model that you have newly trained based on the small subset that you picked and got manually labeled, which is S1, along with your earlier data and earlier models. This is the problem of active learning. Again, you can see that this is a very important problem in the real world. While often it's not covered in academic courses, this is very important. And the reason being, in a lot of real world situations, you might want to go ahead and obtain new data or get manual labels for new data. But you'll have constraints on how much data you can actually obtain, right? In such situations, you want to be smart about picking the subsample of data from the whole unlabeled data and get them human labeled or manually labeled. It's a very, very relevant, important, and an often overlooked topic in machine learning and deep learning models. Okay, here I want you to pause this video. You know the problem context now. Think of simple methods through which you can pick or sample the new data S1. Given that you already have the older data DL, which is already labeled, you have the large amount of unlabeled data du, and given that you also have the initial model M0 that was built on DL. Again, M0 can be a simple linear classifier or a deep learning model, doesn't matter. So please pause this video and think of how you will solve this problem. Okay, so I'm assuming that you have thought through a little. I'll give you one simple example on how to think about active learning in general. Imagine we have a binary classification setting where we have two classes, 0 and 1. So let's take our whole data du. Let's assume du has n unlabeled points, just xi's. We will pass all these unlabeled points through an initial model M0, as you can see on the screen. When we pass all of them through our M0, we will get a yi hat, which is the predicted probability that each xi belongs to class 1. So your yi hat is probability that yi equals to 1 given xi. You will compute this for all I in your unlabeled data. So for all the n points in your unlabeled data, you will compute this predicted yi hat labels. Now these yi hats are probabilities, right? That this point belongs to class 1. Now these probabilities can range between 0 and 1. Imagine if this probability is very small. Let's say it's less than 0.1, which means you're very sure, or more or less you're sure, that this xi belongs to class 0. This model at least, this model M0 is very certain that this point belongs to class 0. On the other end of the spectrum, imagine if this probability is greater than equal to 0.9. Then the model is more or less sure that this point belongs to class 1. In between is the tricky space. Imagine if the probability that we just computed using this binary classifier is between 0.4 and 0.6. For those points, the model is not sure whether this point xi for which we have computed the yi hat, does it belong to class 0 or class 1? Because it's giving a probability of close to 50% of this point belonging to class 1, which means it's roughly 50% of it belonging to class 0 also. So it is more confused, it's not sure, it is less certain on which class this xi belongs to if its yi hat is approximately about 0.5. So the idea here is, what if we pick all these points xi's whose predicted class probability, or in other words, its predicted probability of yi equals to 1 given xi using the model M0. If its probability is around 0.5, the model is less certain about its class. So let's pick some of these points. Okay, this is the points where the model also would perform probably more errors, right? Will commit more errors because it's not sure what's happening. So let's take some of these points and get them manually labeled. That's a simple idea. And then when I get these new points, or this set S1 of points whose probability of the initial model, the output probability with the initial model is close to 0.5, we will get them manually labeled. And then we'll use it to improve our model 0 and obtain the new model M1. That's the key idea of active learning. Again, what we have just discussed right now, the simple strategy that we discussed is often called as uncertainty sampling. Again, there are a bunch of other variations of uncertainty samplings in active learning. What I have described here is probably one of the simplest approaches. Now I have a question for you. Think about it. How would you extend what we just discussed, the simplest form of uncertainty sampling that we just discussed right now? How do you extend it to a multi-class setting? That's a very important question. Again, think of it. It's a very nice interview question also. Think about it, and it's fun to think about it. All you need is basic concepts of machine learning. That's all you need to answer this question. Okay, so please understand that what we have just described is what is active learning and what is the simplest strategy you can employ in a binary classification setting. But active learning itself is a huge area with tons of concepts, tons of variations. You have stream-based active learning sampling techniques, you have batch-based sampling techniques, you have Bayesian optimization-based strategies, you have reinforcement learning-based strategies. There are a ton of strategies, ton of research that's published on this area. Now, we will not be able to cover all of it in this video, but in future live sessions, we can do a dedicated live session on various active learning strategies and how they work. In case you want to try out a library or tool to perform active learning, there is a very popular library called ModAL, which stands for Modular Active Learning. Very popular library. It implements 6 or 7 very popular active learning strategies for sampling. You can check out this library. It's just a Google search away. And in one of the future live sessions, we will do code walkthroughs and also explanation from first principles of various active learning strategies. I hope this helps you.